Good morning, everyone. Here we're going to test the Yaskawa DC servo drive type CPCR-MR-152G. First, we turn on the DC voltages required to run this drive. We need 24 plus and minus 15 and plus and minus 10 for the speed reference. Now we apply 220 three-phase to RS and T. We've already, when we turned on this power strip, applied 110 to terminals U and V. That makes the control voltages for the drive. There we go. Now here's the DC motor that we're going to use to test this DC servo drive. It has tach feedback. Now on this DC motor it has 7 volts per 1000 RPM on the tach. There's our enable switch, and we're running. Now let's go back the other way. Move our enable switch to energize the other relay. There's 2 relays on here. Now, when we go the other way, bring our speed reference in the opposite direction. It's pretty complicated to hook this thing up and run it, but when I get to the house, I'll show you how to hook this thing up and make it go. Once you get it hooked up, it's a nice running drive. You can watch this contactor over here. This one here is for clockwise, and this one's for counterclockwise. This contactor here comes in when you energize the RS and T, 220 volts, 3-phase AC. Did you see that contactor close? And the motors weren't running clockwise. We'd speed it up with the potentiometer, slow it down. This connector right here is where the speed reference, plus and minus 10 volts DC, comes in. Here's the enables, clockwise and counterclockwise, and the tach comes into this connector right here. Now, when I run it in the opposite direction, it's odd how they do this, but I have to move the enable and then increase the speed reference in the opposite polarity. So say for instance right now we're going negative with the speed reference. What I have to do is I have to turn the drive off, move our enable to the counterclockwise enable, energize, and this contactor comes in. But now I have to bring the speed reference back the other way to the positive. There we go. To the positive voltage. It's odd the way that is. Now I can close both of these contactors at the same time and then servo back and forth with the speed potentiometer. Let me show you that. Okay, I'm going to jump. The clockwise and counterclockwise enables together. And now, this switch right here will close both of the clockwise and counterclockwise contactors. Now, we can servo back and forth. Makes a different noise on the motor when I do that. It's noisier. Do you hear that? Now this isn't the motor that was designed to work with this drive right here, so I imagine that's all part of that mismatch and why we're making so much noise when we servo back and forth like that. Alright folks, there you go. That's how you run this Yaskawa DC servo drive. Now, like I said, when I get to the house, I'll show you how to hook all this up. Look at that. There's a lot of wiring right there. Well, that's what you got to do sometimes when you don't have the machine to wrap around these devices you repair. All right, we'll see you in a little bit. Now let's look at the waveforms on the A and B terminal from the drive that makes this DC motor run. I'm going to enable the drive to run. Look at that. Let's increase the speed. This is 20 volts per division. Now we're up to about 40 volts DC. You can see the power devices that are being switched there to make this 40 volts DC. Let's slow down. There's 10.4 volts DC. I'm going to stop the motor. We're going to run the other way. Enable the drive. Look at that. Now the motor's running in the opposite direction. And there's 40 volts DC right there. So we went 40 volts positive in one direction and 40 volts negative in the other direction. There we are at 0 volts. And the motor's not running. Isn't that amazing? Alright all. Hope you enjoyed that video. It was a lot of fun hooking that drive up. I always get a kick out of all the wires it takes to hook this drive up. That's amazing. Okay. Hope this video helps you to hook up and test your Yaskawa DC drive. We'll see you next time. Evening all. Happy Thanksgiving. Alright, let's talk about connecting the Yaskawa DC servo drive. CPCR-MR-152G. Now here's the main terminal board. We connect to the UV terminal, 115, 110, 120 volts AC, and that makes the isolated voltages for the firing sections and the monitoring circuits. We connect R, S, and T with 220 volts AC 3-phase. That makes the DC bus voltage to run the DC servo motor. Down here on terminals L, A, and B. A and B are where you connect the armature of the DC servo motor. And here is a power choke that connects from A to L. Now we'll go up and look at the control connections. Connector 3CN is a white Molex connector, and I'll show you the pinouts of that Molex connector. Pin 1 we connect plus 24 volts DC. Pin 2 we connect plus 15 volts DC. Pin 3 negative 15 volts DC. And pin 4 ground. Now 2, 3, and 4 are from one external power supply, and the 24 volts is from a second external power supply. The plus and minus 15 volts DC go to the regulators on the control board, and the regulators make the DC voltages for the CMOS logic on that control board. The 24 volts, they turn on 24 volt relays that in turn control the turning on of the main clockwise and counterclockwise contactors. The ground up here of that 24 volt DC power supply from the second external power supply goes through clockwise and counterclockwise switches. When we close either or both of these switches, those large contactors, the clockwise and counterclockwise contactors, close. We have to connect pin 5 and pin 7 to that 24 volt DC ground through these two switches. Alright, we're almost there. This is complicated. Almost there. Hold on. Here we are at the top, finally. Up here is the plus and minus 10 volt DC speed reference. That goes to pin 3, and its ground, this is from a third external power supply, its ground goes to pin 4 on the 1CN connector. Here is the tach from the DC motor, and that tach goes to pin 1 and 2 of the 2CN connector. The same connector of the clockwise and counterclockwise enable switches. A couple more sheets to put up and we'll be done. This is probably the most complicated drive that I have to test, and being complicated because of all of these connections right here. It takes a while to hook this thing up. Usually I can put 220, 460 on L1, L2, L3, a motor on UV and W, a speed reference, a master enable, and clockwise or counterclockwise. This right here, this right here is complicated. One of the most complicated drives that I have to work on. Next, we'll put up that 3CN Molex connector and the motor, the actual motor hookup. The actual motor that runs on this drive over here, it's a CUP motor made by Yaskawa, and it's type UGC-MEM-08-MC58, and it has a feedback unit of model TFUE-05Z-C7. I never ever get this motor and drive in the shop at the same time, so I've got to use the DC motor that I've got in the shop. Now the DC motor that I have has a 7 volt per 1000 RPM tack. So for every we get that motor running full speed right there, we'll have 7 volts out on the tack going into this pins 1 and 2 right here. Don't get them backwards. You get the tack or the armature backwards from each other, and that motor will run away. You've seen it on a couple of my videos where I'll test a Maxi Maestro or something and get those backwards, and that motor will run away. It'll go full speed. Then when I get the tack or the armature wires aligned correctly, then I've got control of the motor through the speed potentiometer. Now before we look at that Molex connector for the plus and minus 15 and 24 volts DC inputs to the control board, and the military connector on that CUP motor, I've got a little chart down here in the corner of my hookups. If the speed reference is positive going into 1CN pin 3, we turn on 2CN pin 5. That's the counterclockwise input to 2CN. If the speed reference going into 1CN pin 3 with respect to pin 4 ground is negative, we turn on the 2CN pin 7 connector to go clockwise. Now what we can do, if we want to servo clockwise and counterclockwise, we can close 2CN pin 5 and 2CN pin 7 at the same time. Then we can use the pot to move counterclockwise and clockwise as we saw in the test. Now let's go look at the Yaskawa DC servo motor feedback connector and the 3CN control voltage connector. Here we have 2 half moon pins, pins 1 and 3, and half moon pin over here, pin 5, and a circle pin in between here, pin 2, and 2 circle pins on pins 4 and 6. Now pin 1 here is the plus 24 volt DC input. Pin 2 is the plus 15 volt DC. Pin 3 is the minus 15 volt DC. That's on this side of the 3CN connector. And these 3 pins over here, 4, 5, and 6, are ground. So we have an external power supply for the plus 24, and it's ground. A second power supply for the plus 15 and minus 15, and ground. Now for the feedback connector on that CUP motor, Almost there, folks. This is a long one. This is complicated, hooking this drive up. That's why it takes so long to talk about the paperwork. Now we had to get sideways to get all this in the picture. Here is the feedback unit connector of the Yaskawa CUP DC servo motor. Here's the keyway right here, and pin A, B, C, D, E, F, G, and H with I in the middle. I not being used, it's no connection. All you need to run the CUP motor on the DC servo drive are the tach feedback on pins H and G. H being minus tach and G being plus tach. That's these two pins right here, G and H. You also have an encoder. If you want to test the encoder, apply 12 volts DC to pin E and ground to pin F. That's these two right here, E and F. And on A, B, and C, you will have square waves, encoder output. Now, when you rotate the shaft of the motor clockwise, channel A on pin A will lead channel B on pin B. That's these two pins right here. When you rotate the shaft of the motor counterclockwise, pin B square wave will lead pin A square wave. That's these two pins right here. Now C is the Z output. That's your home pulse. You have one pulse per revolution of that shaft of the motor. So you rotate that shaft one time, and at some point you will see the Z pulse. Pin D, common, is frame ground. That's frame of the motor. There you go, folks. Wasn't that fascinating? How you can hook things up like this and test them. I think that's the funnest part about this job right here, is after you do a repair, you can test these things. If you know how to hook them up. That always takes the longest, is trying to figure out how to make things go. I always enjoy it when you come over and see what we're doing at the shop, and I hope this helps you to test your Yaskawa DC drive and Yaskawa DC motor with this feedback right here. Thank you very much for stopping by and seeing what we're doing next. Hope you're having a good day, and we'll see you next time.